Thank you for accepting. Hi, Alex. Thank you for accepting our invitation to join Beambasket and share your valuable knowledge with us about um, partition supervisors. So, uh, passing it to you, Alex.
Yeah, thanks for having me. Apologies for all the reschedulings. I'm glad that we finally got together today. Let me share my screen. All right, let me know when you guys can see my live book.
We can.
Good. All right, cool. So in this talk, I'll be going over scaling up your processes and supervisors with Partition Supervisor. And for those unfamiliar, Partition Supervisor is something that came out with Elixir 1.14, and so this is this is some new stuff, and I've had the chance to play around with it, and these are some of my learnings that I've come across when trying to implement Partition Supervisor and lean on it. So we're going to start off with some theory. We're going to go over some of the fundamentals. We're going to talk about what makes the Beam so special. We won't deep dive into this. I feel like this topic has been talked about quite a bit, and there's some phenomenal talks on this. But we'll kind of lay down the groundwork so that we all kind of understand the fundamentals. Talk about the components that the Beam gives to us, so that we could build upon, and we'll see how that ties into partition supervisors. We'll also talk about treating the Beam more like an operating system and less like a simple runtime. This is something that Chris McCord has said many times in his talks with Phoenix. He says that Phoenix is not your application; it is merely one part of your application. And so we'll kind of put this to the test later on when we take Partition Supervisor for a test drive. And then we'll talk about the various supervisors that we have at our disposal via the Elixir standard library. After we've kind of gone over that theory, we'll put all this to the test, and we have a little bit of a real-world problem that came up in one of my previous companies that I was at. I was at a telecom company, and we needed to do some event aggregation and publishing. So I've kind of modeled the problem here that we're going to be going over after that problem that I solved there. And we're going to design a solution with a single supervisor initially, and then we're going to try scaling it up with Partition Supervisor and see is it as easy as 1, 2, 3? Do we just say Partition Supervisor, do the thing, partition my stuff? We will find out if that's true or not. And do feel free to interrupt, ask questions at any time. Everything's in a live book, so we could actually do some live coding if we want to break things, if we want to test things. We have that at our disposal. So a little bit about myself first. I'll try to be really brief here, and how I came to Elixir. So I did my undergrad and grad at RIT, and I worked primarily with Java, C, and C++. One of the graduate courses that I took was a programming language concepts course, and we did a lot of functional programming there. It was Common Lisp, Haskell, and Prolog. And after using those 3 functional languages, I came to the conclusion that functional programming is utterly useless. I think I said, quote unquote to my friend, and something that I would never do ever again. Lo and behold, 10 years later, that is very, very false and couldn't be farther from the truth. And during my master's, I actually specialized in computer graphics, and I wrote my thesis on ray tracing and optimizing ray tracing on parallel hardware, specifically on NVIDIA CUDA capable graphics cards. And this was one of the first times where I actually dove into parallel programming via CUDA. And it was one of the first times I really felt like I had superpowers, where I could render a photorealistic scene like this in just a couple of seconds, and it was performing mounds and mounds of computation under the hood. So this feeling, kind of gets shelved for a little while in my early career, as I worked with C#, Java, PHP, Python. I didn't really get that sense of superpower as I was working with those languages. Not to knock any of those languages or ecosystems, but I always felt like these runtimes had some inherent limitations to them, right? So with PHP, for example, If you needed to increase the load of your server, you went into your Apache config and up the amount of PHP instances that Apache was running. Same with Python or JavaScript. You always had something at the operating system level that would horizontally scale your application, like I think for JavaScript, what is it, Fusion Passenger or something like that. And at the operating system level, it would just run multiple instances of your application. And that was how it got around some of its concurrency limitations, right? But even then, if you hit the same instance on the operating system and the event loop was blocked or what have you, that request was still waiting in line because that instance just wasn't serving any requests due to the event loop. So after doing this for a few years, I was really in the search for something better. There had to have been a better way to build applications. So around 2015, I started doing some research. I said to myself, what languages, what runtimes are out there that really have concurrency and parallelism as a first-class citizen. So one of the more popular languages back in 2015 that I came across was Go. I read the book Go in Action. I can't remember the name of the author, but it was a good book. Go, the concurrency model, so they have CSP as their concurrency model, just left a little bit to be desired. I found it to be a little fragile, and this is actually something that I saw in industry a couple years later after I maintained a Go microservice that eventually got rewritten in Elixir. But yeah, it wasn't really the concurrency model that made me feel warm and fuzzy and like I had superpowers. So after that, I read another book. You guys may be familiar with Elixir in Action. The first edition came out in 2015. And after reading that book, I was totally hooked. It took a while to kind of forget all the OO stuff that I learned over the years. But just reading the book, watching talks from Chris McCord, Jose Vadlim, Sasha Urich, I just knew this was a good platform to build my applications in for the foreseeable future. Then in 2016, I got my first job writing Elixir professionally, and I've been writing Elixir ever since. I think somebody unmuted. Somebody have a question?
No.
Oh, okay. So since then, I've been happily working on the Beam. I maintain a few libraries, Promex, MJML, EX, Doctor, whole bunch of nifty little things that kind of scratch my own itches. So I've open sourced a lot of that. Anytime I can, I try to give back to community libraries and tools. I'm also a host on the Amazing Beam Radio podcast. I wrote a book with Bruce Tate and Frank Hunleth on building a weather station with nerves, which was a lot of fun. And then I'm currently working on another book called Elixir Patterns with Hugo Barahona. And the content of this presentation is actually pulled from this book. So in this book, we try to cover kind of some high-level ideas in Elixir. How would you structure supervision trees if you want to build kind of components in your application that can be consolidated into a process? What does that look like? If I want to build a cron job process, what does that look like? So we try to take a lot of things that we've done, over the years professionally, and consolidate them into nice patterns that you could reuse in your own applications. So this is currently a work in progress, and hoping to have a release out later this month with some of the content from this presentation. All right, so the Beam, what makes it so special? This is obviously not an exhaustive list. This is just some of the things that I appreciate day to day as I program with Elixir. Immutability. I didn't appreciate it at all when I was taking my my university classes, but having written production applications in a team environment, I think immutability is something that you just can't ignore, right? There have been way too many bugs that I've come across where somebody creates an object, passes a reference to an object to another function. For a little while, that function doesn't actually mutate the state, but then someone down the road comes in, changes the object under the hood, and given that you're passing things by reference as opposed to to value. Now you have trickle effects that are tough to track down. So I think immutability is a huge benefit in a production and team setting. So that's one of the things that I really love about Elixir and the Erlang virtual machine. The fact that everything runs inside of a process and all of your processes are fairly scheduled across all of your cores is a huge benefit. You no longer need to reach out to the operating system to kind of fill in these shortcomings that your language or your runtime has. The Erlang virtual machine takes care of that 100% for you. You don't need to worry about blocking the entire VM. You don't need to worry about utilizing all the resources at your disposal. It's handled for you at the runtime layer. It checks so many boxes. It's not even funny there. The fact that processes can communicate via message passing makes concurrency very, very easy. And this is actually one of the problems that I had with Go when I was learning it, was communicating over the Go channels. Seemed a little fragile to me, especially when you're passing references back and forth through those channels, as opposed to just raw messages that were copied, right? So there wasn't that sense of shared nothing concurrency in Go, and so that I saw led to a lot of production issues for, in the Go services that I was maintaining. So the fact that all this is taken care of for you at the runtime layer in Elixir and Erlang is amazing. And then we have a lot of constructs at our disposal via OTP, like GenServers, supervisors, registries. A lot of these behaviors that are just given to us via OTP help us build concurrent and parallel applications in a very maintainable and consistent way. Not to mention that we also get clustering at the runtime layer, as opposed to needing external dependencies like Zookeeper or Console or anything like that. The best talk that you can probably watch to really deep dive into what makes the Erlang virtual machine so special is the Soul of Erlang and Elixir by Sasha Urich. Definitely recommend watching that. All right, so what is a process? Let's talk about some of the fundamentals here. So everything on the beam runs inside of a process. It is the unit of code execution on the beam. So they're really easy to spin up and spin down. It's encouraged actually that you start processes for things, and they could be short-lived, they could be long-lived. Their behavior is very dynamic in that sense. You can have thousands of them running in on a single beam instance. It's not as if you have to worry about hitting any kinds of limits. And I think there are actually Erlang flags that you can pass to increase the limits on how many processes that you could spin up on a single instance. But it's nice because all these processes have their own isolated memory space, their own heap, stack, and mailbox. And when a process dies, just that memory space is cleared out. So you don't get a lot of the problems that you see in like Java or Go, where you have these global garbage collection events that kind of slow everything down for just a small window of time. So you have very, very reliable and consistent performance characteristics from your Beam applications. Like I mentioned earlier, processes communicate with one another via message passing. And you can kind of think of them as independent entities or programs inside of your larger application. Kind of like Chris McCord said, even Phoenix is not your application. It's just one part of your larger application. And all these things kind of run on the same virtual machine instance, and they don't necessarily stomp on one another, given that the schedulers in the VM are giving everything fair time slices. So what are some? So these are some kind of abstract ideas. What are some concrete things that you could actually do with a process on the Erlang virtual machine? So you can use it to store state. You can make a singleton process, and that could just keep track of some state. And then, given that it's a singleton process, and you could reference it by name, everything else running on the VM can hit that process and get that data or add to that data or what have you. So you can use it to store state. You could do it. You could use them to perform cron jobs in the background. One example of those is in the Promex library. I pull a lot of internal Beam metrics, and then I create Prometheus metrics out of those. And so all those are running in the background. Every once in a while, polling the Beam and seeing what the what the statistics of the virtual machine are, and then it creates Prometheus metrics. So great for background work.
A
Does
question,
somebody?
Alex.
Yeah, sure.
So I spoke with a few people from finance background,
Mhm.
and their question was about security, like
Mhm.
is Elixir secure? And I did not have a proper answer. So if someone asks you about security in Elixir, and specifically if they're finance domain people,
Mhm.
what answer would you give them?
I wouldn't say that Elixir is less secure than any other runtime inherently, right? The applications that you build in Elixir will only be as secure as you make them to be. So you can make an insecure JavaScript application, you can make an insecure Go application, you could even make an insecure Elixir application. So that really comes down to how you structure your application, and then there's nothing necessarily inherent to the Beam that would make it insecure. So if you want security at your application layer, you just need to make sure that the entry points into your application are well-known entry points, right? So maybe you put all your applications behind a load balancer, and only the load balancer is publicly facing, and everything else is inside of a VPN. Inside of the application, you do proper authentication and authorization. So users that shouldn't be able to perform things actually can't, because the application ensures that they can't do those things. I wouldn't say there's anything on the Beam that makes it less secure than any other platform. Does that answer that question?
Yeah, it does. Thanks.
Yep. And actually, I think Erlang Solutions published it was like a white paper or a case study a few months ago about how they're using Erlang in a lot of the fintech space. So I think actually the performance characteristics of the Beam make it a great candidate for fintech solutions. And again, security is just as secure as you make it.
Okay,
So
I will check and I will ask people too.
yeah, and I can send you that document, that Erlang Solutions document later.
Yeah, thanks.
Yep. Was there another question? I think I heard a ding in Google Meets.
Just to add here, like two things. Having worked in financial industry, I used to come up with these kind of questions, and just two things is like libraries in Elixir, whether it's Acto with preloading, postloading stuff, or it prevents SQL injection by default. So it's definitely nudging you in the right direction. But the other thing that I have experienced is like over all these years, Elixir is the language which is easiest to upgrade. So whenever a new version of Elixir or Erlang runtime comes up, like in 99.99% cases, it doesn't break your existing stuff. And the things that gets up to date are like tend to be more secure than others. So that's definitely a great point about Elixir. Just a normal observation here.
Yeah, that's a really good point. I didn't even think about that. Yeah, Elixir is ridiculously easy to upgrade library versions. I don't think I've ever had a problem where it's been a whole day wasted upgrading things. So that is a very good point from a security standpoint. Is if it's easy to upgrade and keep things up to date, you probably will do it, and so you'll be taking care of any security issues as they come up. Good point.
Okay, thanks.
Cool. Any other questions, or I think we're good. Cool. Yeah, so we can use it for cron jobs. We can use processes to supervise and monitor other processes. So given that supervisors are like everything else, processes under the hood, we can use them to monitor other processes, spin them back up, stuff like that. We can even use processes to initialize our applications. So in a lot of applications that I've deployed, I actually have a GenServer that's first or second on my supervisor list, and it'll perform the migration in the init callback, which blocks the rest of the supervision tree from starting, which is on purpose. And then out of the box, I have migrations running. Don't have to do any other kind of wiring or work, and it's ridiculously easy. Following that same kind of pattern, I block in the init callback, and I've been able to hydrate some cache or whatever, some data into persistent term or ets. And by the time we get to the Phoenix endpoint supervision tree, all of these dependencies are already in place. So when the server starts, you don't have like a race condition where now the server started, now you need to hydrate the cache because you might have requests coming in that lean on the cache, and that cache isn't ready. So it's very nice that you can actually initialize your application with these same constructs, and so that when it comes time to having them be like customer facing, they're ready to go, no problems. You can also create worker pools with processes, and then everyone's favorite task async stream. You can do all sorts of parallel processing and stress testing with task async stream. Again, not an exhaustive list, just some things that kind of I do day to day. All right, so this idea of treating the Beam more like an operating system and less like a simple runtime is a very powerful one. I think it's something that after you've begun reading and programming in Elixir kind of becomes apparent to you, right? So given that you can have many processes running simultaneously on one virtual machine instance, you effectively have kind of like a microservices architecture, but as opposed to being separated over the network, they're all running inside of the same virtual machine instance and can very quickly and in a performant way communicate with one another without any issues. I mentioned that Chris McCord has said that Phoenix is not your application; it's just one part of your application, and this is what he's talking about, where the Beam is effectively your application or your where your application is running, and Phoenix is just one part of that, and that's possible due to the guarantees that the Beam gives us. So every process has a fair time slice on the CPU. Nothing is going to tear down the entire virtual machine and hog the CPU so that nothing else gets a fair time on the CPU. So it does a very good job of managing the compute resources on the computer and then giving them to your application. So, and then after processes are terminated, kind of like I mentioned before, a very localized garbage collection event occurs, and only that memory is reclaimed, and you don't need to do any kind of global sweeps or anything like that. And to just kind of paint some more color here for the operating system metaphor, the same way that Linux has systemd, the Beam has supervisors, right? So systemd on Linux controls the life cycle of services on Linux. You can define what services depend on other ones, which services need to be restarted, when, stuff like that. You can do the same exact thing with supervisors on the Beam, right? And at a high level, supervisors give us that chance to initialize processes and child supervisors in a repeatable way. So when you have a list of child processes specified in your supervisor, they're always going to start in that same exact way. So it's deterministic, it's reliable. You don't necessarily need to worry about that. You can introduce some issues there, but that's more of a programmer problem, right? So if process A starts before process B, but process B requires some data from process A as it's starting, you just need to make sure that that's happening in process A's init callback, because that'll block the supervision tree, and then when you get to process B, it's ready to go and can actually interact with process A's data. So just some small things that you need to be careful about as you're building applications. But luckily the Beam gives us all those constructs to make starting applications and kind of orchestrating them pretty easy. One of the best things that supervisors do is they restart processes when they die. So if your process encounters an error, it'll, depending on the supervision restart strategy, it'll either restart just that process, or it may start everything, all of its sibling processes as well, if they're kind of interconnected and depend on one another. So this gives you a lot of control over your application, and this is where the let it crash slogan kind of comes into play, right? So if your processes encounter a weird state, just let them crash, start over again. Maybe you missed some data in the meantime, but it's far better than the entire system going down or becoming unresponsive. So you've localized the blast radius of any issues, and you've kind of restarted things to a known good state. They also give you an opportunity when you're shutting down the virtual machine. If you're passing a sig term to the application and you've set up all the exit signal traps properly, you could actually tear down your processes carefully and in a coordinated fashion. So really quickly, in Elixir, we have 3 supervisors that are given to us through a standard library. So we have supervisor, which is probably the most well-known, and this is useful when your child process list is known ahead of time. So if this is like a library, like Promex or something like that, or even Ecto or Phoenix, you know ahead of time what the components of that library are going to be, and you can kind of encapsulate all those inside of one supervision tree. And then as a consumer of those libraries, you could just add that one entry into your supervision tree, and now you've inherited, kind of all that orchestration in the background, and all you had to do was add one line to your application. So supervision trees are a good way, or supervisors are a good way of encapsulating things that you know ahead of time, and you don't need any kind of dynamic starting and stopping semantics there. On the other hand, you have dynamic supervisor, which is pretty much the exact opposite. You have no idea what child processes you're starting, and processes may come or go at any time. So dynamic supervisor by default starts with no children, and then you could add them and terminate them as you see fit. And the supervisor will still start things if they're halted in a non-normal fashion, but you can have processes come and go rather quickly here. And when you pair this with the registry module, you can have a very lightweight process-backed key value store. So your registry would have the ID, or the UUID, or the name, whatever you want. Look up the PID of the process that's started under the dynamic supervisor, and then anytime you want to mutate some data or store some cache, you could have the key, look up the process PID, and then you could update your cache or do whatever. So you kind of have like an actor model key value store there using registry and dynamic supervisor. And then as of Elixir 1.14, we have Partition Supervisor, which is what we'll be taking for a test drive here shortly. And what Partition Supervisor allows us to do is it allows us to replicate either a supervision tree or processes across any number of partitions. By default, it'll be the number of schedulers that you have up and running. So I think on this M1 MacBook Pro, I think I have 10 cores or something like that. So by default, if you don't override the partition value for Partition Supervisor, it'll start 10 instances of whatever you give it. And the nice thing is that it deterministically routes messages to the appropriate partitions. So if you have maybe your messages need to be routed based on a user struct, the same user struct will end up at the same partition every time, as long as the data inside of that struct is the same. So if your ID is the same and your name is the same, you'll go to the same partition every time, which is nice. You don't want non-deterministic behavior in your applications. All right, so let's solve a real-world problem now. So what are we building? In our hypothetical scenario here, we have an API as a service, and we're going to be taking note of which customers hit the API and how often they're doing that over a window, a time window, right? We don't want to keep track of every single little call that people are making to the API. That might be a little too much, and we don't want to flood that data, and we actually don't have any use for that data. So we would rather just summarize and aggregate data over a discrete time window, and then just write that to the database. So our requirements here are, every 5 minutes we aggregate and we flush that data. For the purposes of this demo, we'll do every 5 seconds, so we're not waiting around 5 minutes for flush events to occur. But our initial solution, naive solution here, is we have one supervision tree that has 2 processes under it. We have the event collector, which just collects and aggregates cast messages. And for this application, maybe it comes from Phoenix plug. So after we do our authentication and our authorization plugs, maybe we have another plug after that that just passes the current user that's making this call to the event collector, just a cast, so we don't slow down any API calls. Very, very lightweight, not intrusive. And then we have the event flusher process, and this takes all of the aggregated messages out of the event collector, and we could write them to timescale DB. We can push them off to another service. We could do whatever we want with it at that point. For this little demo application, we're just going to be printing it to the console because it's easy that way. So that's kind of our proposed solution for this this hypothetical problem. And this is something that I've done in a couple of spots. Very, very similar. You have a kind of like a buffer collector and then a flusher. So let's dive into the code here. And if anyone has any questions, feel free to stop me and we can play around with each individual snippet of code here. So this is the single supervisor solution. So we'll install Kino here because we want to be able to visualize the supervision tree that we start up. And then we're going to define a user struct. This is probably something you would have, in Ecto or something like that. But for now, we're just going to have the ID, the name, and the subscription plan. Very, very lightweight, just to kind of demonstrate how this all works. And then we have the event collector GenServer. You'll see not a lot of lines of code here. Very, very lightweight. Not a lot going on. Our client-facing API just has our start link function. So this is going to be a singleton, and you know that because we're passing the name equals underscore module. So we could reference this GenServer by the event collector name. We don't need to do any other roundabout work to figure out what the PID is. We could just access it right by name. And we make use of that in these helper functions, count event and flush event counts. When we do the cast here, we just call module directly. And then we pass it the user, and then the handle cast has it matches on the count event. And then, so this is what our plug would be interacting with. It would just be calling count event. Every time it hits that plug, it would cast the user to the event collector, and then it would carry on. And then we have the flush event counts call, and this is what our other process, the flusher process, is going to use to extract all the events out of this process, and then write them to the database, publish them to another service, whatever you need to do there. That kind of depends on your particular use case. So our server callbacks, we initialize the process with an empty map. Very simple. Not a lot going on here. Our handle cast matches that count event that we had up here, and then we also match on the user struct. And then we have our map, which is our GenServer state. And all we're doing there is we're updating a key in a map. So it's going to be the user ID. If the key exists, we're just going to increment it by 1. Otherwise, just set it to 1 because it's the first time we've seen that user. And then we just return our state. Very, very simple. And then our handle call flush events count callback implementation returns the event totals to the caller. So this will be that flusher. And then our brand new state is an empty map. So we start fresh. We aggregate for our time window, we get flushed, and then everything is gone. We start fresh again. So that's kind of that GenServer in a nutshell. And then we get to our flusher GenServer. So this one doesn't really have any client-side API functions. Since it's running in the background, it's just regularly flushing the other process. We start it in the same way. It's got a name, so this is also a singleton process. We can only start one instance of it by default. And then in our init callback, we allow for the flush interval to be configured. So by default, it's 5 seconds, just so we're not waiting around for output to show up. And then we call our handle. We invoke our handle continue callback here. So as opposed to just returning our state like that, we invoke the handle continue callback so that we can actually schedule when the next flush will occur. So our handle continue here just sends a message to itself at the specified flush interval, and then we return our no reply. And this is where our flushing is actually occurring. So perform cron work is the name of the message, and so we handle that via handle info, and then we call that client-side API event collector, and we flush all of the events. If the map that we get back is an empty map, there's no reason to do any action. We could just skip. But if the map does have some data, we'll log it for now just to make it easy to see. But if you wanted to publish this to another service, you would use like Finch or whatever, publish this to another service. If you're writing this to a database, you would do your ecto calls here, or reach out to your appropriate context to do those writes. So this is where you would actually handle that batch of aggregated data. And then after we're done with our handle info, we do the same thing we did in our init callback. So we return our new state, which is just the flush interval, and then we call the handle continue to schedule the next flush. So this is a nice pattern for kind of putting together a cron job gen server. So let me run that. So we have it in our live book. Let me make sure. Yep, I ran that one. Cool. And then we come to our summarizer supervisor. So the supervisor that manages these two processes. So we have a module here that uses the supervisor macro. This is also a singleton. So we start with name module. And our only two children are event collector and event flusher. And that's it. And our strategy for restarting processes is 1-for-1. So if event collector has any issues, only that one's going to be restarted. If flusher has any issues, only that one's going to be restarted. And with this, we can actually start our supervision tree. Any questions thus far, or should I get it going? All right, I'll run it. So our first thing here is we check to see if it's already running. If it's already running, we stop it. We'll start the supervision tree. We'll render it, and then we have a couple of test users here. And we do a little bit of a stress test to see how long it takes to get through 100,000 events, right, at a max concurrency of 2,000. So let's run that guy. So here's our supervision tree dynamically rendered. So this lines up pretty much exactly with what we outlined in the previous live book. And then we'll see here that with just this very simple supervision tree, we were able to route about 20,000 messages per key, per user, right? So given that we have five users here, we're just doing a random. We kind of expect the average to be about 20,000, which it is. So, and that was it. It took just a couple seconds. We got through all of that. So let's actually bump up this this number here. And we'll see that output keeps getting dumped now, in order to get through the 500,000 messages. So this is those aggregated totals over that 5-second window. So we'll see that we start at second 46, 51. That's plus 5 seconds, plus 5 seconds, plus 5 more seconds, and at every one of those intervals, for user ID 1, they had 25,000 events. For user ID 2, 25,000 events. Et cetera, et cetera. And then we wrapped up everything in about, say, 20 seconds. So 500,000 events aggregated, no problem, in 20 seconds. So it shows you how far you can get even with just a single supervision tree and just a couple of processes under it. Sometimes you don't need anything complex. Something like this will do just fine for your particular use case. So don't worry about building too much web scale. The constructs that we have available to us, even as simple as they look and straightforward, they're very, very capable. So that is that guy. If we run this one, we'll see that we do the same thing. We check to see if it's running. We stop it, and then we restart that summarizer supervisor, and just kind of see what's going on under the hood when you're starting the supervision tree and when you pass it a couple messages. So self here denotes the live book process, and so that one is spawning the summarizer supervisor with this call right here, and then summarizer supervisor is spawning the event collector, which is the first child in the supervision tree, That one is done, and it acts back to the supervisor that it's done starting, and then it goes to the next child in the supervision tree, and it spawns the event flusher. Same exact thing happens. The event flusher acts back that it's been started, everything is good, and then once all the children are started for that supervision tree, the summarizer supervisor acts back to the live book process that the supervision tree has been started. Everything is good, and then we have our two cast calls here, which are making their way to the event collector, so that we can keep track of events that are incoming. So we can kind of see and visualize how all these processes are started and how they communicate with one another. And then, yeah, given that we only had 2 events, those are done rather quickly. Cool. So is scaling up easy? Can we just throw Partition Supervisor on this, and all of a sudden we have web scale? If if handling 100,000 messages in 5 seconds isn't enough, can we do better? So we'll once again start up Keynote here so we could do some visualization if we need to. I copy and pasted pretty much all the same code from the same slide, or the previous slide. So we have our 2 gen servers, we have our slightly modified supervisor down here, because we're starting it as a partition supervisor. I don't know why this comment is there. So can we just start this and replicate this supervision tree n number of times depending on the number of partitions? So let's see what happens here. I think I'm leading a little too much here, so I think everyone knows that it's going to be an error. It is an error indeed. So it's failing to start the process, and it's claiming that it's already been started. And the reason for that is, if you'll recall, our summarizer supervisor was a named supervisor, so that's a singleton. The other 2 processes were also singletons. So the partition supervisor, when it tries to start a subsequent version, it will fail because there's already instances of those processes running, and it can't start any new ones. And we can kind of test that theory by saying, if we only have 1 partition, and we start it, and we can indeed start it. There's our PID for our supervisor. So we see that we can't partition this easily because the way we architected it initially, things are colliding and not working together. Does that make sense? So far, so good?
Yes.
Cool.
Yes.
Nice. All right. So how do we fix this? Let's see how we can make this
Yeah.
web scale.
Arpan, do you have a question?
Oh, we do have a question. What's the question?
Yeah, I just wanted to clear my understanding. So here, with the partition supervisor, we were with the initial schedulers online. If we had, say, 4 schedulers, then the partition supervisor would spin up 4 instances of our summarizer supervisor, which would in turn start our event collector and flusher gen servers for each of those summarizer supervisors, right?
Correct. Yeah. So as I have it written right here, the idea was, we just want to start 4 versions of it, if that's how many schedulers we have. We just want to start 4 versions of this supervision tree.
Okay. And the
Okay, so
problem
then-
was that, and the problem was that we used the module name as the gen server name, so it was giving us an error due to the duplicate name, right?
Correct. Yeah.
Okay.
So we need to do a little bit more work on our side in order to get this supervision tree running in kind of a partition supervisor world.
Got it. Thank you.
Yep. Cool. So in this, I think this is our last one, so we're coming right to time here. So in this last live book, I fix up our naive implementation and get it ready for running in a partition supervisor. So we'll define the user module there, same as before, nothing changed there. The event collector looks very similar. The notable parts here is that we got rid of the name option, so we can no longer access this this gen server by name, so only by by PID or by a registry. And under the hood, the partition supervisor module actually leans on the registry. And if you guys have ever seen the via tuple before, what it allows you to do is access a process, but resolve its PID through some kind of registry. So before we had underscore module here, and we were just casting to that module. We can't do that anymore because it's not a named process. And so now we need to say, based on the user that we got, we need to resolve an instance of event collector that lines up with this user. So we pass the via tuple. So the first element of this tuple is the atom via. We say that it's via a partition supervisor, and then we give it our instance of our partition supervisor, and then what we want it to route based on. Right. So in this case, we're routing on the term user. So that's a struct. So we're routing based on that term. So every time a request comes through for this user, they're going to end up at the same partition, which is what we want, because we don't want to aggregate metrics for user one across disparate partitions. I don't think that's not a very good solution there. So for every request for the same user, we want to go to the same partition. So this is the biggest change in our event collector. And we do something similar with the flush event counts. But as opposed to passing the user, we pass the partition number. And if you look at the docs for Partition Supervisor, you could either pass it a term, and it'll actually take a p hash of that term, and it'll route you appropriately. Or if you pass it an integer, you'll get routed to that number partition. But this adds some kind of a little implicit kind of complexity here, because we need to make sure now that all of our partitions are getting flushed. Since this GenServer isn't responsible for flushing itself, it needs something else to flush it. Is there a question?
The phash will be on user number or something, user unique, right?
So there's an Erlang function called phash, and it'll effectively give you a clamped hash based on any term. So if you pass it a struct or a map, if you pass it the same map over and over again, you'll get the same exact value at the end.
Yeah.
So that's what allows you to deterministically pick the correct partition.
Yes.
Hey Alex, I've got one question from my side, and is there any limit on how many number of partitions you can create, or maybe the children for a particular supervisor?
I don't think there's any limits that are imposed on you in Partition Supervisor.
Mm-hmm.
So you could scale it as much as you'd like until you hit some kind of process limits on the beam.
Okay.
But it doesn't necessarily make sense to scale too much, because then everything is context switching and you're time slicing everything.
Okay, so if I want to do some analysis on this, let's assume that you are running some computation or modeling on a e-commerce website. Now e-commerce website got so many products. Okay,
Mm-hmm.
so if you have around 64 product categories, and if I make 64 partition in this thing, okay.
Mm-hmm.
To compute different counting or maybe aggregation or some sort of that operation. So if I just spawn this kind of processes, will it hit the VM in terms of memory? Or
no, you'll be fine. Yeah, if you have, so let's say your partition key is the category of the product on your e-commerce site. 65 partitions is not that that's not that much, especially if all you have under those partitions is a flusher and a collector. That you're not going to be hitting any VM limits there.
Okay. So it may occur that one of the partition may get too much data. Let's say for example consumer electronics, it may have so many products, but something like a kitchenware, it may have only 10 or 20 products. So in this case, if I'm doing categorization based on product ID or some maybe your user ID, where you classify users based on platinum, gold, or silver, and each category may have different count. So in that case, even the performance will be the same, or is there any way to calculate the performance, or maybe faster of the process?
Yeah, so there you're going to have to come up with a better partition strategy. So in this particular example, I treat all users the same. Don't care about any of their metadata. They're just going to get routed based on whatever phash comes back with. But if you need to be a little bit more clever about what partitions, or if you need to be more clever about how you're load balancing across all of your partitions, then you need to think about that a little differently. So if you know from the get-go that let's say one category of products is more popular than others, maybe you have a partition supervisor just for that category, or maybe you have
separate one.
Exactly. Yeah. And then,
Okay,
maybe that partition supervisor has five processes under it, and then you kind of load balance across those 5. So it really depends on your use case. This particular example kind of assumes that all the data coming in is going to be balanced equally. It doesn't, like, nothing's weighted more than anything else.
Okay. Yeah, thanks.
Was there another? I thought I heard another Google Meet ding.
I was suggesting that can we route multiple things to say, for instance, in this example that we were talking about, if a particular category has more requests coming in, so we have more partitions which are devoted to that category. So say if there are a lot of gold members and there are only few silver members, then we have more say 3 partitions dedicated to gold and only maybe 2 to silver, so that more requests are routed to the gold partition.
So what's the question there?
So I am asking that is it a possibility to do this sort of thing where if certain kinds of categories have more load, then we dedicate more partitions to that category?
So that I mean, in this, so if you look at this code, it's not necessarily going to work that way, because every time you hit so as opposed to user here, pretend it's product, right? So if your thing here is, let me just move the mic, product dot category, this is always going to end up at the same partition. If the category is, home appliance, you're always going to go to the same partition.
Right.
And
Yeah.
so this is what I was saying before, where if you know for a fact that home appliance is your busiest category, and you're going to be getting tons and tons of events there, you might want to make a partition supervisor for each category, and that way the category that you're gonna invoke, and then you could load balance across that particular partition supervisor if you need that kind of granularity.
Okay.
But I mean, as you saw in the previous 2 live books ago, even with just 2 processes, a flusher and a collector, we were getting through 100,000 events in 5 seconds. So this is the time where you need to implement, kind of like a naive and simple solution and measure. If it's enough and you see that the ceiling is way above where you currently are, you're probably fine. If you see that what you've implemented is just squeaking by, then you need to reach for something a little bit more complicated, right?
Okay.
And so that's why you need to always measure your production applications and see where your real bottlenecks really are.
Okay. And with this partition supervisor, can we specify a custom hash function instead of something like phash? Do we have the ability to do that?
I think so. I'm not sure though. There are a couple options that you could pass the partition supervisor. I don't know if that may be one of them. I haven't looked into that.
Since it accepts integer, you can always do that.
Yeah, that too. Yeah.
Yes, we can write something custom, is what I believe. Arpan.
Okay, makes sense. Yeah.
Thanks.
Cool. Any other questions?
None for now.
Cool. Yeah. So did this part make sense? The fact that we're routing here properly based on user, and we're routing here properly based on partition, and how now this creates kind of like an implicit constraint that we need to make sure that all of our partitions are getting flushed, as opposed to leaving one behind. So that's all good. Good. Cool. And then the server callbacks, 100% the same with the other version. So we're just initializing our state to an empty map. We're updating depending on the user that got passed in, and then when we flush, we return the aggregated totals to our caller, and then an empty map. So we'll run that guy. Let me see here. All right. So event flusher. Very similar changes here that had to be made to the to the other gen server. So we drop the name option here. So now this is no longer a named gen server. We now pass in two options. So we have the flush interval, how often we're flushing it for the cron job. And then the flusher itself needs to know what partition it is so that it can invoke the corresponding collector gen server. And we do the same thing. We invoke the handle continue callback. We schedule the next flush, and then same exact thing from this side. We just call that client side function, flush event counts. We pass it the partition that we want, and then we log it out if there's data. Else we just schedule the next flush. So we'll run that guy. All right. So this one had a bit of change, if you remember. We still want to start this supervision tree as a named supervisor because we only want one summarizer supervisor running. And so thinking back to the questions that you guys had, let's say you had very, very busy categories and very not so busy categories. Maybe you have home appliance summarizer supervisor, and that has its own partitions. And then maybe you have miscellaneous supervisor summarizer, and so then you kind of partition it yourself at the application layer. So we started with a name, and then just to make it a small visual, and we can play around with this, we start with 3 partitions, and then our children, as opposed to being just event collector and event flusher, are now partition supervisors, and each partition supervisor will start 3 event collectors, and then 3 event flushers, and then we pass in the partition option to make sure that we get 3 of each. And then with the flusher, since the process needs to know what partition it actually is, we also need to pass in this option here called with arguments, and then that way we can store in the state what partition that particular flusher is. So if we go back to the init function, you'll see that we're able to get the partition key out of the options that were passed in. So if we run that, all right. And then if we go to start this supervision tree, let's see if it runs as we expect. So we have our top level summarizer supervisor. We start our event flusher partition supervisor, and we have 3 processes underneath. And then we have our collector partition supervisor, and that also has 3 processes underneath. And then if we look down here, we'll get 3 log statements because each flusher is hitting each collector. And for example, this particular process was keeping track of users 3 and 5, and these are the events that it aggregated. This collector was keeping track of users 1 and 2. These are the totals that it had, and the last one just had 4, just had user 4 in there. And then if we bump this up to, let's say 1 million, we rerun that, we should be getting output pouring out every 5 seconds, and we have our counts in there. So, and we'll always get 3 log statements, 1 from each flusher. And so that'll work its way through 1 million messages rather quickly. And that's Partition Supervisor in a nutshell.
This is amazing. A dumb question.
No questions dumb.
Different nodes for Partition Supervisor anyway.
Say it again.
Different nodes and Partition Supervisor.
Oh, like can you split your partitions across multiple nodes? Is that what you're asking?
Yes. Can I split it across different nodes in a cluster?
I would say as it stands right now, I don't think you can, because Partition Supervisor under the hood leverages registry, and that is only a local registry. It's not a like a cluster registry. So there you would have to use something like libcluster to cluster your nodes together, and then something like swarm or horde and you're probably going to have to rebuild this kind of construct, but using distributed primitives like horde or swarm.
Okay, yeah, I see a better future.
Yeah, but I mean, as we saw here, so let's see. So we started this one at second 06. And we went all the way to 46. So it took us 46 seconds of flushing. And we probably could have turned up the max concurrency here even higher, but we got through 1 million events in less than a minute. So it's I mean, even as it stands, pretty performant on a single node, and we didn't have to do a lot of work to get there.
Awesome.
Wow, this is amazing.
Oh, thanks. Any other questions about this or anything else? I can answer anything else if you want.
Okay, Alex, just a question about Livebook. How do you create those links for next and previous? Like
that I can't tell you. It's a secret.
okay.
No, it's just the markdown link. Yeah. So if you let me see here. So if you look in Vim, and I can actually make this repo public, but I just have I have an index live markdown. So this is the entry point into my Livebook documents, and then I just have a next link that goes into slides.
Got it.
And 1, 2, 3, 4, 5, 6, 7, 8, 9. And then my shell script just makes sure that when I run the Livebook, I open it up and a browser is automatically opened with the index page.
Got it.
Yeah, I can open source this one.
Yeah, that would be awesome.
One
Yes, sir.
question. What if I mean, I believe that the partition supervisor restart strategy would have similar options as a normal supervisor, right?
Correct. Yeah. So if you look, where was it? Yeah. So if you look here in the definition, if I recall correctly, there's partition supervisor. You can also, yeah, you can pass in the strategy. So I just passed in partitions, and with arguments, you could also pass in max restarts, max seconds. So depending on how many failures occur over a time window, the strategy, yeah, you could pass in all that.
So just to I mean clarify things in my head, I'll just try to reframe a situation. So like we were talking about products and categories earlier, and let's say I have 1 million products and I need to spin up 1 million gen servers for something on each product. But so I could do a dynamic supervisor for that, and as and when products get added to the queue, I mean dynamic supervisor can take care of processing needs to be done.
Yeah,
how
you
would
could do that way. I think oh, go ahead.
And the other way is that I can create a partition supervisor based on category and then go via that route. So I mean, in what case would the dynamic supervisor would do just fine, and in what case would the partition supervisor really shine?
Yeah, so I think in order to make that call, you need to kind of pinpoint what your problem really is, right? So if you're using a dynamic supervisor to keep track of the state of a product, and this, I think I actually wrote a blog post very similar to what you're describing like a year or two ago, where I have a registry and a dynamic supervisor, and the registry has the ID of a book, and then it maps to a PID, and then the dynamic supervisor just starts, I think, like 4,000 or 5,000 processes, and the state of that book is inside of that gen server, right? And I think for that blog post, I did it for the purposes of keeping track of like keeping track of your inventory, right? So you would keep the state of the book in the gen server, and as people bought the book, for example, you would decrement the on-hand inventory, and then you could very quickly return back an error if you run out of inventory or something. So I think using like a registry dynamic supervisor works very, very well in that kind of a use case, where every single process has nothing to do with any other process, right? It's an embarrassingly parallel problem. One book state does not impact another book state. So I think that is very different to partition supervisor, where maybe you're going to be aggregating things, right? So with a partition supervisor, many different products will flow through the same processes. So like all the same users will flow through this one, the same users will flow through this one, even though they're different from this one, and then the same for the other one. So I think it really depends on your use case there, what supervision strategy you go with. So if everything is totally separate, nothing really matters or interacts with anything else, dynamic supervisor works well there. And you can actually start, I think in the sample here, or in docs rather, they actually show you how to start many dynamic supervisors under one partition supervisor. So if a lot of your processes are coming and going very, very fast, one dynamic supervisor may not be enough to keep up. You might need 5, 6, 10 dynamic supervisors to deal with all of the processes coming and going as quickly as they are. So it's not necessarily just processes that you're putting under the partition supervisor. You could also put other supervisors under the partition supervisor, and then it just comes down to how do you architect your problem and how does your data actually flow. Does that make sense? Or
so I mean, then my question really boils down to: have you experienced any such problems that has been elegantly tackled by this sort of strategy? I mean, it's pretty new, so I can't think of anything that I would come across. Probably, if I do, I'll write a blog post. Have you come across any such things?
I mean, in production, I've used the registry dynamic supervisor pattern pretty frequently, and that's mostly for keeping track of let's say a user is performing some actions on the web app, and I just need to keep track of some state until their session is done or whatever. I usually just spin up a registry and dynamic supervisor, and given that the characteristics of that data are ephemeral, like I don't care if maybe there's a deployment and that data goes, I don't necessarily care. If I did care, it'd go in the database. But I've used that strategy to deal with processes spinning up, storing some customer or user state in a process, and then the process goes away when that state is flushed due to some user action. I haven't used Partition Supervisor in production yet because it just came out a little while ago. But I'd imagine for streaming, for kind of like streaming events, kind of what I laid out here, I'd imagine it's very applicable, where you just have a flood of events coming through, and maybe you need to do some on-the-fly aggregates or analytics. I feel like this is a very easy way to kind of disperse the problem space into various partitions. So I think this is very valuable there, maybe for stream processing.
Okay, Alex, I understand we are out of your time, but like, how much? Can we continue a few more minutes, or how is?
Yeah, I can continue for a little bit longer. I think I have a meeting in like 20 minutes, so I think I have a hard stop at the half hour.
Okay, thanks.
Hey Alex, yeah, like this question is like in general. So if like if you are getting data from the external system, let's say for example your database is like hosted on some other server or maybe some other node, or maybe you are getting very big nested JSON file. Okay, so in that case, like will it be partitioning at the start will be helpful, or how you define this partitioning strategy? Like if the data is hosted on some other server, or you need to wait for that particular file, like for example JSON file or XML file, to come up on the current server completely and then go for partitioning?
I didn't follow 100% there. So you're saying what if the like as opposed to, let me see here, as opposed to the data coming from like another process. So like right here we have the collector keeping a map and then the flusher reading that map, right? So you're saying that as opposed to having this kind of relationship where the data is all inside of the VM, what if the data is somewhere else? Is that what you're saying?
Yeah, correct.
Okay. So how would I structure the application in that case?
Yeah. So for example, like if you have a user database and that being hosted on Redis, okay. Now you have Ecto, which you provide a query and everything. But like if you are doing some analytics or some sort of a operation, you need complete that Redis data on the current server or current VM. So downloading that particular dump will be very much expensive. So writing a Ecto query which will eventually partition the data or maybe make a subset of it, then dumping on the particular server will be helpful, and then partitioning it, or taking complete data and then partitioning it will be the best solution. Or maybe even I do, if any case I'm missing right now.
Yeah, I mean, so you could use. I think I follow what you're saying now. So you could still use the partition supervisor here. It sounds like effectively what you would be doing is you would be deleting this part of the tree. You don't need this anymore because you're no longer collecting data inside of your application. You just need to collect data from outside of your application. So you could use this part of the tree still, and just have cron jobs and partition those cron jobs accordingly. So maybe you have 10, 20, 30 partitions running cron jobs, and they're just reading data out of Postgres or out of Timescale DB, Redis, wherever, and they're doing the summarization after the fact, right? So the data has already been written to the database. Maybe it's just been written in a raw. Every event has been just logged in the database. I don't know. So everything is in a raw format, and you need to perform some kind of batch data processing after the fact. You could still do that. Yeah, you would just have the flusher, as opposed to calling it flusher, maybe call it something else because it's not flushing stuff, it's actually summarizing. So rename it so it's a little bit more clear what it's doing. But then each process under here, yeah, maybe you just still have it be a cron job. It fetches some time slice of data out of the database, or out of like whatchamacallit, out of RabbitMQ. Maybe you're aggregating all your events there. Although if you're going that route, I'd probably just go Broadway if you're reading stuff out of a message queue like Kafka or RabbitMQ, and then just deal with the messages after the fact. So
okay.
Yeah, just to summarize and get a better understanding of the use case for this partition supervisor, from what I understand from the example given in the docs as well. So is it correct to say that one of the options for like whenever we have a scenario where the supervisor itself is a bottleneck in our application, where we are starting too many children and maybe the dynamic supervisor is not able to keep up, and we want to scale on the supervisor level so that our supervisor doesn't become a bottleneck. It might be a use case for partition supervisor, so that we can add some sort of parallelism maybe on the supervisor level.
Correct. Yeah, that's a good summary. Yeah, that's absolutely right. And I would, the reason I structured the talk the way I did, where we have the single instance and we try to move to partition supervisor, is because that's what I would do in real life too. I would start with a naive solution and just see what the limits are. At what point does this very simple supervision tree break and it just can't keep up with the traffic anymore? And so I would do that in real life too, in production. I would only deploy one supervision tree unless I had beforehand all the data in front of me to let me know how much traffic this is going to get. But usually you don't have that. So you're going to production with a hypothesis that this will keep up with the traffic that I'm going to throw at it, and then measure and keep an eye on it. And then you could see, okay, this is not enough. I now need to start leaning on more more tooling, or I got to distribute this application and make sure that the load is spread across two totally separate instances. That's why it's always important to measure what's actually going on in production, because then you know exactly where you need to focus your efforts. Because most of the time, if you're not measuring and understanding how your applications are actually behaving, usually your hypotheses will be a little off, and you'll be attacking a part of the problem that turns out is not even part of the problem. So you need to measure and understand how things are behaving so that you could actually fix those particular bottlenecks.
Makes sense. Yeah.
Anything else? Any other questions?
I think we are good now.
I had one more question if there's no other questions from related to partition.
Go ahead.
Yeah. So we were talking about this message passing at the end of like at the beginning of the talk. So I had this common question like which often pops up in my head from whenever I started learning about functional programming. So we say when we are doing message passing and we are not dealing with these mutexes and locks and polluting the same shared memory and leading to all kinds of problems. But whenever we pass messages, we say we are copying the message, and I just think that say we have a big data structure in memory, so copying this multiple times over functions, how does this play out on the memory level? And I like say we have a big list, maybe like maybe a million entries or something, and if we are not passing it by reference and copying the entire thing in memory, and then the caller function also has to keep a copy on itself and it's sending it to another function, and now it's copying the entire thing in memory. So how does it play out? Is there any explanation to
Yeah, sure. So message passing specifically is when processes are communicating. So if one process needs to send another process some data, that's going to be a total copy, because now you need to go from that process's memory space to another process's memory space, right? So that's how message passing works. If you're just calling one function to another, under the hood, the Erlang virtual machine leans on data structures called persistent data structures. And there's a whole Wikipedia page on persistent data structures. And it's actually not copying the entire thing when you're making a function call. It's actually, if you're updating that data structure, then it's making kind of like a fork in memory of that data structure, depending on the scope that you're in, and it's only relevant to that scope. But 99% of the data structure still shares its data with the previous scope that invoked that function, right? So yeah, so this is a whole class of data structures that you can look into, and this is kind of the only way that it makes functional programming performant, right? You're absolutely right. If we had to copy every single little thing every time you invoke the function, it would be brutally slow. So thanks to persistent data structures, from our perspective, everything is immutable. Under the hood, the virtual machine does a very good job of making sure that it only copies data structures when it absolutely has to, and when something has changed, it's only slightly modifying a portion of it. And then with some pointer magic under the hood in C and C++ land, one scope of the call stack might have one pointer into the persistent data structure, and then in a totally different part of the call stack, there's a different pointer to that part of the persistent data structure. But to us as users, we don't have to think about this. We don't have to worry about it. And thank goodness, because managing your own memory can be a pain in and of itself.
Yeah, this makes sense. And one more question that I had was like coming from some work that I've done on RORs, I see a lot of errors related to this typing and type system. Things getting called on nil, and sometimes a method is expecting an array, it got an integer and things blew up. And I did a little bit of Rust, and I see and I find it how very elegant how it handles these sort of things, and the language always knows what is the type of the data it is receiving, and it forces the programmer to handle cases where such as nils and stuff. So in Elixir we have dialyzer, but it sort of gives us some cryptic errors at times. And how do you feel, like what do you feel on this space? I've seen, I think Joseph Valim is working on something like set theoretical types or something, but yeah, what are your views on this?
Yeah. I am curious to see what comes out of the set theoretic types. To be honest, I mean, I don't ever feel like I'm missing types. Yeah, I might be eating my words in like 4 or 5 years, but at the moment, I don't feel like I'm missing types at all. I mean, granted, when I was programming in say, C, C++, Java, very different type system than Haskell's type system, for example. But the fact that the language is so simple as a result of not having all these extra bits of syntax. I have looked at Rust. It's tough to read sometimes. There's backticks randomly here, a pound randomly here. Like there's a lot more that you as the programmer need to learn in order to be effective in Rust and kind of get those guarantees. Versus on the other hand, I think Elixir is very easy to write, very easy to read. Going back to somebody else's code, I know exactly what's going on, even though I didn't write it. It's in a totally different domain. So I think there's a trade-off there with how simple the language is and how it handles types, right? At least that's my position. So I prefer this trade-off. I like the language being very, very simple, not having a lot of constructs or syntax and stuff like that. And the time that I save, reading and modifying other people's code, I make up for that time by writing, very extensive test suites, which those are always beneficial anyways, since at the end of the day, even if you are in a, let's say, like a Haskell or a Rust, a lot of times you're going to be getting data from impure sources, whether it's your database, whether it's an API call, and sometimes you can marshal that into a format that you can read, and other times you need a little bit more, you need to be a little bit more dynamic. And I think we see that even in TypeScript, where in a lot of production code bases, once in a while, there'll be an any somewhere because there's just no other way around it. So I mean, at the end of the day, it's all trade-offs, and a lot of it's also personal preference. Having worked with Java, C, C++, those obviously have some form of types in them. I don't miss those days. I'm very happy in Elixir, where I have a very small set of types. I have tuples and lists and maps. It's a very small set of types, and I'm able to get all my work done without having to worry about, oh, here I need to pass in a buffered reader map factory, and here I need to pass in this. And I always found that to be way too much ceremony. So granted, there's a little bit of you're not getting all the safety you possibly could because the language is not or the compiler is not validating these things, but I think it gives you a lot of agility as a programmer, and you can make up for a lot of these deficits with with a very good test suite, which I personally would rather have a very comprehensive test suite than a compiler type checking everything. I imagine that might be that might get a lot of comments on YouTube there.
Yeah. Actually, you should listen to his podcast also. Arpan, you should listen.
Okay, I'll check it out.
Since we are running out of time, Alex, what would be the good way to contact you if there are any questions in future? Anyone in audience has questions?
Yeah, sure thing. Twitter's probably the easiest the easiest way to reach me. I'm usually posting kind of what I'm working on there, or some cool tips and tricks. My DMs are open, so yeah, just find me there. Shoot me a message. It's AKOUTMOS is my Twitter handle. So that's probably the best way to reach me. I also have a blog, akoutmos.com, so akoutmos.com. You could leave comments on any of my articles there. I try my best to get to the articles or the questions and respond in a decent amount of time. And I also have a newsletter, so sign up for that. And if you want to stay in touch.
Sure. Newsletters is also good. So I have heard a lot about your analytics library, telemetry library.
Promex, yeah.
Maybe in future, if you want to give a talk on it, we can talk about it sometime later.
Yeah, that would be great. I'm currently, if you look at the commits, I was doing a lot of work over the weekend. I'm trying to get it updated since the monitoring space has changed a little bit since open telemetry has kind of become a de facto standard now. So I'm trying to get Promex updated to lean on a lot of those OTel libraries. A lot of the Grafana dashboards are also a little out of date. So I think I'll be saying, forget the old Grafana versions. Everybody's getting the new Grafana dashboards, and you need to upgrade Grafana. So I'm going through a process of updating everything there. So we could definitely have a chat after that's done.
Okay. There is one more message to the audience today. We have SpawnFest upcoming week, this weekend. SpawnFest is 48 hours hackathon where you can join as a person or as a team and build something in 48 hours, showcase it to the world. Amazing people, amazing judges, a great way to show yourself to the Beam community. You can write in anything, Elixir, Erlang. Yeah, that's it.
Cool. Thanks for having me, guys.
Alex.
Appreciate it.
Yeah, it was a great session, Alex. Thanks a lot.
You're welcome. You're welcome.
Yeah, the examples were pretty great, and like these sort of examples always like hypes me up for Elixir more. So thanks a lot. Yeah.
Good. I'm glad. Yeah, I tried to make sure that the examples were real world, because I mean a lot of times we stay in the abstract with Elixir and processes and supervisors, but how do we actually use these day to day? And so that's what I tried to do.
Okay, are the examples on GitHub or somewhere? Open to public or closed?
It's a private repo. I will push all my local changes to that repo, and then I'll send you a message, and then you can put it in your show notes or whatever.
I will write in YouTube description the link. Okay. Yeah.
Okay. Yeah, that sounds good. Yeah, I'll send that to you right after this.